In this video, we're going to be making an introduction to spectroscopy because I want to cover in few videos some UV visible, IR in doing, giving you like tips to solve problems and then head it into NMR. So as a general, when we have, in the spectroscopy methods, we have the interaction, say, of light of some sort over your sample matter. Let's say this a cuvette or something like that, but some specific light, and depending on the wavelength that we're working in, we're going to be looking into UV visible spectroscopy or IR or NMR. So then we're going to be analyzing what comes after, and that can be plotted in different ways. For the UV visible, we're going to be looking at specifics, landmarks. When we do IR, we're going to be looking at a series of absorption bands. And then we're going to be doing later videos on NMR, both proton and carbon NMR. And here we're going to be doing several things, so signals, and we're going to be learning where are they, and the shapes, meaning splitting here, chemical shift, and splitting patterns, etc. But right now, let's talk about just the interaction between light and say, some electromagnetic radiation. And we know this is related. Planck equation, this is Planck constant, that's frequency. And so directly proportional the energy and the frequency. And we can also express that with the wavelength. So this is the speed of light. This is a wavelength. So notice that it is an inverse relationship. So here for the larger the wavelength, the less the energy. So that's what we're doing. So understanding a little bit of that. So in the electromagnetic spectrum, let's say that I'm here in the visible range. And then higher in energy, we're going to be looking, this is UV. And so, and less energy, here we're going to have the IR. And so, in this sense, frequency is increasing in this direction, and of course, energy. And in that way, let me do this. So you will be increasing in wavelengths going over to this side. So in lower energy, so higher energy over here, let's say higher energy, so higher frequencies in here, lower energy of the electromagnetic radiation, so larger wavelengths. So here we'll be doing later on in the microwave region. That's where the NMR goes, and we're gonna obtain different type of information. Infrared will go here, and this is of course the red part of the visible, and here is like the purple. And even higher in energy than that, we're going to have gamma rays. And gamma rays have been used in surgery, for example. They're very like laser type, targeting, for example, tumors in surgery. And higher energy even that are the X-ray, and we know that we use those in medicine to get images from our bones, etc. So here we are. So the spectroscopy that we're going to be studying first is that UV visible, so and see what kind of information we get out of that interaction, electromagnetic radiation in our sample. And then we're going to be looking into IR spectroscopy and learning what information. Essentially, here we're going to be learning about functional groups. That's the main information that we're going to be seeing. And in the UV visible, we're going to be looking at conjugation. And in here, where you do the NMR, we're going to learn more fine-tuning details about connectivity and types of H's and type of carbons. So that's what we're doing. So now I'm going to go over a little bit of the UV visible in the next video.